Hello, this video is for an individual project I am doing at Metropolitan State University for my ICS-382 Computer Security course instructed by Professor Jennifer Grant. My name is Doug Skayer and my project is about Linux server hardening using oscap, an open systems tool used to audit a server's security settings based on a policy such as HIPAA, PCI DSS, or others. Before starting, I must make a disclaimer. This video is solely for educational purposes. I am not liable for any damages that could be caused by using this demonstration. The video discusses, recommends, demonstrates operating system changes to make for Linux server hardening purposes, which if not done without proper testing, full considerations for the implications of each change, could result in degraded operation. What is SCAP? SCAP is also pronounced SCAP, and it stands for Security Content Automation Protocol. It is a method for using specific standards to enable automated vulnerability management, measurement, policy compliance, and evaluation of systems deployed in an organization, including, for example, FISMA. The National Vulnerability Database is the U.S. government content repository for SCAP. An example of an implementation of SCAP is OpenSCAP. So SCAP is a standard that allows for many different tools using its protocol to implement different security policies. OpenSCAP, or OSCAP, is what we'll be using for this demonstration. For the remainder of this tutorial, we will cover security policy determination, OSCAP tool installation on our Linux server, security policy evaluation, and security policy remediation. Security policy evaluation is where we run the OSCAP tool to get a report on the state of our system based on the security policy we have chosen. This will expose Linux server settings that are not secure and are recommended to be changed. Security policy remediation is the changing of the insecure settings to comply with the security policy that we have selected. The first step to security compliance as it pertains to the hardening of a Linux server is to define what policy we want to use. Unfortunately, there is no universal security policy that could be applied everywhere. Each organization has different needs and different security requirements. The policy decision must consider the IT infrastructure used for the organization that uses it. Different policies may be used in any one infrastructure based on compliance need and the operating systems used. For a healthcare example, some systems might use HIPAA security policy for the internal systems that support patient information. Other systems in the same environment that handle credit card transactions might use PCI DSS security policy, and still others that use cloud services may use the cloud security policy. For the purpose of this demonstration, the standard security policy will be used. The next step is to install the oscap tool, but there needs to be an overall plan to follow in our environment. The installation methodology I would recommend is applied in 3 steps. I expect this would be in line with most organizations' change management requirements. The first is install all your testing should be done on a personal system. This is so that you can understand the operation of the tool, the timing of the various steps in the processes, and understand what is impacted with each change that is made. If something goes wrong, we want it to be done in here in our personal test environment where we can easily recover without affecting others. We don't want to make these mistakes, in even test environments that affect others can be disruptive, so we don't want to do that. The second methodology step is to install OSCAP, evaluate, and perform remediation in the application's test environment. This environment will be used differently than our personal test environment in some ways, so we'll need to understand and test for that. If possible, it would be time to engage the application's vendor and our organization's support group for that application to understand if there's any requirements for the application that implementing the security policy would actually break. As an example of this, we see in our environment, FTP cannot be disabled with some applications because they rely on that to transfer files. But unfortunately, FTP transfers files in clear text over the network, so it's not secure from the standpoint of confidentiality. So we need to document the changes that we have made for future reference. After the test application server has been remediated to the extent it can be, we need to allow a full period of testing to be completed. This means that time has passed for most functions to have run within the application, including scheduled jobs. The third step in our methodology would be to implement in production. At this point, we can have the confidence that our changes to be implemented will not impact production negatively. If it does, at least we have gone through the effort to test it, and then we would need to determine why it failed in production when it seemed to test okay in our test environment. There's some difference there that would need to be determined. So now that we understand our security policy implementation methodology, we have one last task to prepare for the installation, and that's to get a system backup. The reason for the backup is to be able to recover our environment if something goes wrong. So for this test environment, I'm using OracleVM VirtualBox, and it's running a Linux CentOS version 7 VM on it. CentOS is freely available Linux distribution and is a downstream source of Red Hat Linux, and that just means that it's very similar to Red Hat. It's not exactly the same, but it's pretty close, close enough to do testing with. So in this environment, a Linux backup can be completed using Oracle VirtualBox's snapshot technology. And I'll just run a quick snapshot here. And that just takes a couple minutes. During this time, just like as a background, snapshots track all changes made to a VM from the point in time that the snapshot was taken, so meaning from this point that I just took the snapshot. If we run into an issue with our security remediations that we cannot resolve on the Linux server, we can restore our snapshot back to this point in time. So it rolls back all the changes that were made, and we can go back to the starting point. So this is not the same as a full backup that would be used to recover from problems outside our changes, such as, like if you have a bad disk or something that you'd require a full restore. This is just a snapshot that gets rolled back. So now we have our backup. Okay, so now that we have the backup, we can perform the installation, and oscap is installed. This is probably the easiest part of the overall process, really. So we can install using yum, and with the command that we see here, yum install scap-workbench. That installs the entire thing, so that's easy enough. Let's see, I just wanted to mention that if you're not familiar with yum, it is the most recent package manager used with Red Hat Linux and Linux distributions. Yum is a command line tool that is used for installing commonly used packages in the Linux environment. You can also remove or update packages as required using yum. Patching the server regularly is easily done by running yum update, so it's very, very handy tool, very easy to use. So yum is actually already, or not yum, but scap is already installed on our server, so we're ready to actually run the evaluation. And so this is the oscap command that we're going to use to run the evaluation. It's quite long. It actually wraps around to a second line here. But kind of some of the key points is, oscap, that's the base command that we're using for everything that follows our arguments to that command. And so you can see we're going to do the evaluation. We're using this profile, which is our standard profile. So there's this R formatting file output that's given as an option that we won't use. The report might use it that we view later, but we don't actually use it. We are generating a report that's putting this file name in our web server's root directory, and then this is whoops, that's a reference to the standard file, the standard that's used, that file there. So we'll just run that, and it'll take a minute. And as it runs, you can see each rule there, the title, the rule, and the result. Some are going to pass, some are going to fail. And these are all operating system settings that are being checked as part of the policy. You could use this text output if you wanted for whatever reason, and that's something you could capture. But it also, like I said, generates a report that's a web report that we can look at, which is a lot clearer, a lot easier to see, a lot easier to read. Just another few seconds more here. Okay, there, it finished. So now it generated a report, and we can go look at the report. So looking at the report, the top part contains detail about OScap policies and the operating system being evaluated. In this case, the report points out that there are some configuration differences between Red Hat, which the policy is written for, and CentOS, which is what we're using for the evaluation. So we'll just kind of scroll down here to the compliance and scoring. So first thing I want to just look at is the rule sets here. You can see that there's 51 rules that were evaluated, 20 passed, 30 failed, and there's one indeterminate, means it was probably incompatible, maybe a Red Hat test that, because it's CentOS, it doesn't evaluate correctly. The next thing here is server severity of failed rules. So we have one rule that's really low severity at 28 medium and one that was high. The next thing we want to look at is the score. This 81.67% is a score that is evaluating using the CVS ranking of vulnerabilities, and somehow it calculates the number based on that. Coming down to the rule overview, just want to start, you can kind of see that, so the rules are grouped, maybe like you can see by system settings and authentication, various groupings like that are logical. You can see the severity, the low mediums, and there's going to be a high one down there. The results pass or fail. And here's the one that wasn't checked. Here's a couple high ones. Here's a high one that failed. We'll take a look at that. Just wanted to kind of show the entire report here. So you can see quite a few of them have failed. So we just want to go back to this one here. It's the only high severity rule that failed. So we just want to look at that. You can click on it and um, brings up more detail on the rule. And a couple things we want to look at is the description and the rationale. Um, so the description, if an account is configured for password authentication but does not have an assigned password, it may be possible to log into the account without authentication. Remove any instances of null OK option in that PAM file to prevent logins with empty passwords. And empty passwords are it just means no password. So by having this null OK option in the PAM file, that just means the operating system allows any kind of user ID that doesn't have a password um, to be configured, and it'll let it run. So the rationale for the remediation is if an account has an empty password, anyone could log in with the commands with the privileges of that account. Accounts with empty passwords should never be used in operational environments. I should probably also point out that PAM stands for Pluggable Authentication Module, and it is used in authentication with Unix and Linux servers. So null OK is a security authentication weakness and should be disabled to improve security. That is to say, to harden the server. So in this, we can also see that remediation options are shown. There's two of them shown here. So we'll just look at the one here. So one option that you could do is to use these two sed commands to edit each of these files. Sed is a what is it? It's a substitution editor that you can edit files and add or remove things on the fly. If you're able to understand this, you can see that one section has the null OK, and the other section has a space. So what sed is doing here is just editing this file. It's searching for null OK, and then it's replacing it with a space, and it's doing the same thing in this other PAM file. Another option that could be used to make the change is the Ansible option here. That's all this stuff, and I suppose so. The reason that I guess you would use Ansible is if you have many servers in your environment that you want to make the change on. Ansible is becoming more popular because of its capability to simplify administration of numerous servers in the environment. Ansible is not easily deployed and it's got a steep learning curve, but once you understand it and it's set up, you can run commands against groups of servers at the same time. This reduces the total maintenance time because you don't need to visit each server separately to make changes, so it's a big time saver. For example, if you had 100 servers and you wanted to remediate this empty password issue, you could add the provided code and make the change across all the servers. Or more likely, you'd make the changes across, say half of them are test servers. You'd make the change across the test servers 1 week and wait, see if there's any negative fallout, and then the following week you'd make the changes in your production servers using your change policy. So want to take a little bit of a closer look here. So with this PAM issue, this null lock issue, we'll just look at the files and so I just catted both files and grepped for this null OK. And what this is telling is that there's two entries in each file with null OK. and that's basically what we want to remove. And so you could just edit the files manually if you wanted. That's another way of doing it. But since this is a discussion on OSCAP, we're going to use OSCAP to remediate against it. And so I'm just going to first run. So this command is the So this command is the command that'll just run a check against that one empty password rule. And this is, we already know that it's failed, but this is our way of showing the before and after. So it ran the evaluation against the rule and it failed. So now we can use oscap to remediate this one rule. And very similar command to the one that does just the evaluation, but this one also has a remediate option. And this will just take a couple of seconds. Yep. Okay, so a couple of things we see here. There's warnings about references to Red Hat, and again, this isn't Red Hat, so we can just ignore those warnings. But we can see that it's been fixed. So if we rerun our OSCAP evaluation, we'll see that the rule now passes. So this has been remediated. We can also look at the PAM files. So there's no OK entries in any of those PAM files. So this has been remediated, which was the goal. So let's see. I guess all I have left to say is, it would be easier to load the OS and remediate all security policy rules before deploying the application. It's clear to see that, this whole time here, we were pretty much talking about what we need to do around remediating one single issue. And I forget how many there was, but if there was 30 of them, it's understandable that it's going to take a considerable amount of time just to remediate each one, verify that the application isn't negatively affected. So the best case would be to deploy your security policy before you even install the application, and then that way at the time of the deployment of the application, all the details are worked out, can be documented, and put the vendor on the hook for why the application doesn't comply with your security policy. So let's see here. We're at the end of the demonstration. Just wanted to thank you. I hope you were able to get useful information from this video. So thanks for watching.